Okay, we're going to be continuing our course review here. If you haven't seen the first part of the course review, I covered systems of linear relations and quadratics, all the factoring, quadratic equation, finding roots, etc. Now we're going to continue on looking at quadratics, focusing on word problems, and then after that we're going to be looking at trigonometry and centers of triangles. So for this first quadratic word problem here, we have a baseball is hit and its height h in meters at time t in seconds is modeled by the following quadratic. What height is the ball thrown at? So first of all here, to find what height the ball is thrown at, the ball is thrown when the problem starts initially. So since t represents time, initially your time would be 0. So if I want to find the height the ball was initially thrown at, that's when the problem started off, that's when time is 0. So in this case here, you can notice here you get 5 times 0 squared plus 20 times 0 plus 0.8. I end up getting h is 0.8 here. By the way, we're in standard form here, and whenever you're in standard form, that's always going to be your initial value or your y-intercept. So at any rate here, the height of the ball when it was initially thrown was 0.8. 0.8 what? It's measured in meters, so 0.8 meters. So if I want to do a little sketch of this diagram, it's going to look something like this. We know it's a quadratic. We know the leading coefficient is negative. I know it's going to open downwards. I now know that this is my initial starting point of 0.8 meters, and we're going to proceed like that. So let's continue on. Now the next question is saying what is the height of the ball to the ground at 3 seconds? So I want to measure the height of the ball to the ground at 3 seconds. Well, therefore I'm going to let time be 3, and that'll tell me how the height of the ball to the ground at 3 seconds. So you sub in a 3 here, and we'll see what we get here. If you do the calculation on this, you get 15.8 meters. Okay, continuing on here, we want to look at the next question. Next question says, for how long is the ball above 2.2 meters? So we've got our diagram here. If you recall, we have our sort of rough sketch of our diagram of our quadratic. I know that the height from here to here is 0.8 meters. I want to know how long is the ball above 2.2 meters. So let's say we draw a horizontal line here, and this is the line y equals 2.2. What I'm interested in finding is how long is the ball above 2.2 meters. So I'm interested in all of this time here that I'm highlighting in red. So to find that, you want to find when does the ball actually reach 2.2 meters. So what I'm going to do here is I'm going to set my quadratic equal to 2.2, and then I can go ahead and start solving this here. So I'm going to bring everything to one side. And we got 0.8 minus 2.2 is negative 1.4. I'm going to go ahead and divide across by negative 1. And then we're going to use the quadratic equation here. So the quadratic is going to be t equals negative b plus or minus b squared minus 4ac over 2 times a. Okay, so in this case here, notice I chose to use the quadratic equation because I saw the decimal places. I know that I want this to be time. I'm going to get decimal places in my answer. And a quick check there, I didn't really see that anything could factor, so I'm going to wait to the quadratic equation. Doing that, I get t equals 20 plus or minus 10.95 over 10. So you end up getting here two approximate values for time. One is going to be 20 minus 10.95 divided by 10, 0.91 seconds, and then 20 plus 10.95 divided by 10, and that's going to be 3.10 seconds. So we've got 2 times here, and this is the 2 times we found. So this time right here is 0.91 seconds, and this time right here is 3.10 seconds. So how long is the ball above that length here? Well, the ball's going right at 0.91 seconds. It hits 2.2 meters. Now I want to turn the clock on and measure all of this time here, and then stop it once I hit 3.10. So to find that length there, you take 3.10 subtracted by 0.91. That'll be the difference in those 2 times, 2.91 seconds. So therefore, this question here, the ball has been above 2.2 meters for 2.19 seconds. Okay, let's continue on. The next part of the question here is asking, at what time does the ball hit max height? If you notice here this question, this was our original diagram, looks something like this. And I know that if I draw a line going down this way, I know that at 0.91 seconds and at 3.10 seconds, I know at those times there the ball was equal to 2.2 meters. So therefore, these are actually points here. So I know that the exact middle of these two values will give me my axis of symmetry. So if I'm looking to find out what time did the ball hit max height, one option that I can do is I can take my two values I found when the ball is equal to 2.2 meters, so 0.91 seconds and 3.10 seconds, I can average those out. If I average those out, the approximate time the ball hits max height is, I'm actually getting 2 seconds if I round, 2.01 seconds. So that's one way you can find the time that the ball hits max height. You can average out your actual answers from your previous question. The only issue here is these answers were rounded, so maybe your answer is a bit off. If you're looking for a more accurate way, you can go to your original quadratic, which is minus 5t squared plus 20t plus 0.8. And if you remember, the x-coordinate of your vertex, i.e. the time my quadratic hits maximum height, is going to be equal to negative b, which is negative 20, over 2 times a. And if you go ahead and calculate this, you get 2 seconds right on. So I solved the problem 2 different ways. You notice obviously you get very close answers. The only reason that these answers aren't exactly the same is because these answers were a bit rounded a little bit, so it threw off this answer. But either, I'm sure, are more than acceptable. In part B, it says, at what time does the ball hit the ground? Well, the ball hits the ground when time is 0. So in this case here, you set your quadratic, in this case negative 5t squared plus 20t plus 0.8 equal to 0. I'm going to go ahead and do the quadratic right away. Before I do that, I'm going to get rid of that minus sign as a leading coefficient, and we get t equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a, and t is going to be 20 plus or minus 20.4 over 10, and we get 2 approximate values here, 4.04 and negative 0.04. And notice here, this time here would be inadmissible. That's negative time, and that makes no sense for our actual problem. So the answer to this is, when does the ball hit the ground? That's at 4.04 seconds. Now, just to come back to this idea, the reason why we got that is, if you go back to our diagram here, where that negative time came from is that the problem, if you notice here, the problem at this point, this is when the ball hit the ground. This is at 4.04 seconds. That's when the ball hit the ground. This right here is when time is 0. So this is actually would represent our y-axis here. So what we're getting with negative time is they're just expanding, continuing that quadratic, and it's hitting this time here, this is in the negative region. So for this problem here, right, this is your x-axis, this is time. For this negative region here, it doesn't exist for this problem, and that's where that value is coming from. And just a quick observation here, notice if I add these up and divide by 2, I also get my max height of 2. All right, let's continue on. Next problem. So for this question here, we have a city bus sells 12,000 tickets at $1 each. Every time they increase the price by 10 cents, they lose 400 tickets. So they want us to define variables to represent the problem and then find the maximum revenue. So I'm going to let x equal the number of 10-cent increases or decreases, and I'm going to let r be the revenue that you create from this. So they want us to find ticket price that's going to maximize revenue. So how do I express the revenue function here? Well, I know that if I sell 12,000 tickets, I know that I'm going to sell them at $1 each. So at that price there, you're going to have 12,000 tickets that can only be achieved if I sell them for $1 each. What I do know is that every time I increase the price by 10 cents, I'm going to lose 400 customers. So therefore, if I increase the price by 10 cents twice, I'm going to lose 400 times 2. If I increase the price by 10 cents 3 times, so 0.10 times 3, I'm going to lose 400 times 3. If I increase the price by 5 times, let's say, it's going to be 0.1 times 5. I'm going to lose 400 times 5. So therefore, I can just put an x here for the number of times I increase the price, and now I've kind of represented the positive and negative effects. As I increase the price of this value, this value here will decrease the number of sales, right? As the price goes up, the sales go down. So in this case here, we have a quadratic, right? If I expand this out, my leading coefficient is negative. So therefore, if I want to find max revenue, a rough sketch of the quadratic might look something like this. If I want to find max revenue, the only thing I really need to find are the roots. So what I can do here is set my revenue equal to 0 and solve. So if I take my revenue relation and set that equal to 0 and solve, we have two options. Either 12,000 minus 400x is 0, in which case we end up getting that x is going to be 30, or 1 plus 0.10x is 0, or 0.10x is negative 1, or x is going to be negative 10. So therefore, there's two values that we're getting here. These are obviously the absolute worst options for this company. You either decrease the price by 10 increments of 10 cents, which would mean you're selling the tickets for $0 for free, or you increase the price by 30 increments of 10 cents, i.e. you're selling the tickets for $4, and then no one buys them. In the middle is what you want. To find that middle, you just add up your x's and divide by 2, in which case we add those up and divide by 2, I get 10. So the answer to this problem is not x equals 10, but the price that's going to maximize revenue is going to be, take a look at your price relation here, 1 plus 0.1x. I'm letting x be 10, so it's going to be 1 plus 0.10 times 10 is they should be selling these tickets for $2. At $2, they will be able to maximize their revenue. What is the actual revenue? Well, the question doesn't ask us what the revenue is, but the revenue is going to equal, if I let x be 10 here, we're going to get a decrease in the number of people that buy the tickets. If I let x be 10 here, you're going to have 12,000 minus, that'll be 4,000. You're only going to have 8,000 people buy the tickets this time, but that'll maximize your revenue. 8,000, and you multiply that by the new price of tickets, which is $2, you're going to make $16,000 in revenue. As a comparison, what were you making originally? Originally, let's just kind of write this over here. Again, this is not what the question is asking. We've gone beyond what the question was asking, but they were telling us that originally you were making $12,000 selling tickets for $1 each. I'm sorry. Originally, they were telling us that you were selling 12,000 tickets at $1 each. You're only making $12,000. So you can see here, by increasing the price of tickets, you go from 12,000 tickets sold to 8,000, but you double your ticket price and therefore make more money. Okay, continuing on here with the same problem. Now they say, okay, suppose you made this much revenue. What were the possible ticket prices that you chose? Well, now I'm going to take the possible revenue, which is $14,412.40. I'm going to set that equal to our revenue relation here, which is this. Now I can't solve this in this current form. I have to expand everything out, bring everything to one side, and use the quadratic equation. Normally this would be set equal to 0, and you can find the roots and average them out like we did in the previous problem. We don't have that here. I have to expand everything out, bring everything to one side, and use the quadratic. So if I do that, let's go ahead and do that and see what we get here. I get 14, so 412. So expand this out, we're going to get 12,000 plus 1200x minus 400x minus 40x squared. So this becomes 0 equals minus 40x squared. Collecting like terms here, we get 1200 minus x minus 400x is positive 800x. Then we get minus $2,412.40. At this point here, I would multiply across by negative 1. So you get 40x squared minus 800x plus $2,412.40. We're going to use the quadratic equation. I'm just going to divide across by 40. Even though it doesn't divide across nicely, it still cleans up the quadratic a bit here, in which case we get positive 631. Now using the quadratic equation, we get x equals negative b plus or minus the square root of b squared minus 4ac over 2 times a, which is equal to 20 plus or minus 12.6 over 2, and we get two values for x. Either x equals 16.3 or 3.7. So the possible ticket prices are 1 plus 0.10 times 16.3, or 1 plus 0.10 times 3.7, which gives approximate ticket prices of $2.63 or $1.37. So notice with this question here, either they sell the tickets for $2.63 each, or they sell the tickets for $1.37 each. Both of these will yield less than maximized revenue, and that less than maximized revenue is $14,412.40. Okay, let's take a look at the next problem here. In this one here, we have a farmer has $2,400 to spend and wants to build 2 rectangular pastures. The local contractor will build a fence at a cost of $625. Find the dimensions of the pastures that maximize total area. 2 rectangular pastures. So we've got, let's say this is our sort of border of the whole thing, and then there's going to be 2 of them, but they're going to share a side here. And what we know is that I have $2,400 to spend, and I know the cost per meter of fencing is $6.25 per meter of fencing. So now what can I do here? First of all, I need to know how much fencing do I have to work with. Well, if you take the $2,400, that's the amount of money I have to spend, and you divide that by $6.25, that's going to give you the, because every time you spend $6.25, that's going to give you 1 meter of fencing. So by dividing these out, we get the number of meters of fencing that we need, which is 384 meters of fencing. So therefore, you have 384 meters of fencing to use. So how do I express my meters of fencing? Well, I can label this entire expression here with an X. I can label these side ones with Y's, and obviously down here would also be an X. So therefore, my perimeter of this shape is going to be 2x plus 3y. But I know what the perimeter has to be. The perimeter has to be 384. So I have 384 equals 2x plus 3y. Now, the question wants me to maximize area. The area of this shape is going to be what? Well, it's going to be x times y. That's the area of the shape. However, what I need to do is, to maximize this expression, you need 1 variable, not 2. So what can I do here? Well, what you can do is, I now, like I just said, I want to maximize this expression here. What I can do is go to my perimeter formula here, and I can isolate for x or y. It doesn't really matter. I'm going to go ahead and isolate for x. So I'm going to divide across by 2 here. 384 divided by 2 is 192 minus 3/2 y. I'm going to write this as a decimal place. I'll change that to 1.5y. Okay, so now, like I said, I want to maximize this expression here, but I've got these 2 variables. I can now get rid of the x, and I can re-represent that x as 192 minus 1.5y times variable y. Now, what do we have here? Well, I have a quadratic. This quadratic has a leading coefficient that is negative, so it opens downwards. Therefore, it hits a maximum. That maximum is my max area, and that's what I want to find. So where do you find max area? Why don't I just find the roots? I might as well do that because it's already in factored form. So what I can do here is set my a value equal to 0, and now I just want to know when is this expression 0. Well, there's only 2 times. Either y is 0, or 192 minus 1.5y is 0, or minus 1.5y equals minus 192, or y equals 128. So there's 2 values here, 0 and 128. So that max happens exactly in the middle, and that middle is 0 plus 128 divided by 2 is 64. So therefore, our maximum area happens, let's write this down, the max area occurs or happens when y equals 64. But if y equals 64, I can sub it into here and solve for x. What does x equal? X is going to equal 192 minus 1.5 times 64. So x is going to equal 96. So going back to our original diagram, we have each of these y's are supposed to be 64 apiece, 64 apiece, 64 apiece. And this x value here is going to be 96, and obviously the bottom one as well will be 96. So the dimensions that maximize area of this sort of double rectangular prism sharing one side of fencing is going to be, the entire structure will be 96 by 64, or you could break it up into individual pastures, in which case you'd have 96 divided by 2, which is 48. So you're going to have a 48 by 64, two 48 by 64 rectangular pastures. Now we're going to be looking at the trigonometry section. Let's take a look at the first questions here. Solve for the indicated side or angle. They want us to solve for angle x here. And in this case here, notice that I have these two opposite sides and I have these two here. So we're in a situation where I have 3 of the 4 that I want. So this is a sine law question. So if I set this up here, it's going to be the sine of x over 75 is going to equal sine of 125 over 100. So the sine of x is 75 sine 125 over 100. The sine of x is approximately 0.61. And taking our sine inverse, we get that the angle x is approximately 37.91 degrees. All right, let's try the next one. So for this question here, we're looking to solve again for angle x here. Notice we do have a right angle triangle. So therefore, what I have is this angle is directly opposite. This would be my adjacent. This would be my hypotenuse. So as I'm going through this here, I'm given the O and I'm given the A, and that's going to be a tan question. So in this case here, we're going to get the tan of the angle x is equal to my opposite over my adjacent. So the tan of the angle x here is equal to approximately 0.88. And taking that tan inverse, we get 41.42 degrees. So we've got here angle x is approximately 41.42 degrees. All right, let's try another. So for this question here, now we want to solve for this length here. Notice we're in a situation where I have side, angle, side. And whenever you have side, angle, side, we can go ahead and use the cosine law for that one. So in this situation here, I'm going to label my triangle so I can use my cosine law form. So I'm going to go A, B, and C. So instead of solving for length x, we're going to call that lowercase x, or lowercase a, lowercase c, lowercase b, in which case I'm going to use the formula a squared equals sum of the squares of the other legs of the triangle minus twice their product to the cos of angle A, in which case here we get a squared equals 12 squared plus 17 squared minus 2 times 12 times 17 to the cos of 35 degrees. And doing that, I get a squared is equal to 98.79. Taking the square root, we get approximately 9.94 centimeters. So the approximate length of side A here is 9.94 centimeters. For the next question here, you guys can see here we've got side, and they want angle x here. So right away I'd label my triangle ABC. We're going to use the cosine law for this one again. So for this one here, I'm looking for angle B. It is labeled this angle x here, but the way I've labeled my triangle, it's now angle B. So therefore, to solve for angle B, I'm going to have to use formula B. So it's going to be b squared is sum of the squares of the legs of the triangle minus twice their product to the cos of B. Input everything you got here. So this is going to be my B, this is C, this is A, in which case we get 48 squared equals 52 squared plus 65 squared, 2 times 52 times 65 to the cos of angle B. Bringing everything to one side here, we get 48 squared minus 52 squared minus 65 squared is negative 2. 52 times 65 cos of B. And what do we get? So we get negative 4,625 equals, I'm going to go ahead and calculate the product of these three numbers. Negative 6,760 cos of angle B, and therefore the cos of angle B is negative 4625 over negative 6760, and the cos of B is approximately equal to 0.68, and taking the cos inverse, we get B is approximately 46.83 degrees. All right, let's continue. So for the next problem here, we have a window in a building is 18 meters above the ground, okay? From this window, the angle of elevation to the top is 40 degrees, and the angle of depression to the bottom of the building is 42 degrees, and they want us to find here how tall is the building across the street. Okay, so let's start off here. Let's say I got my building, and I'm gonna say the window's right here at the top, and I know it's 18 meters. Now, what I know is that the building that I'm looking towards, I have to look up to because there's an angle of elevation on this. So there must be a taller building going on here. All right, and we have this other taller building on the other side, and I know the angle of elevation to the top is 40 degrees, and I know the angle of elevation to the bottom is 42 degrees. And what the question wants you to find is how tall is the building. Now in this problem here, we can go ahead. We know that the length from here to here is 18 meters, which means the length from here to here would also be 18 meters. So I actually know this is 18 meters. So I don't have to label the entire length here as an x. What I can do is if I can just find this length here, then I can go ahead and actually solve the triangle. Well, I can find this length here because I have myself a right angle triangle going here. I have two right angle triangles. So if you focus your attention on this bottom half right here, I've got a right angle triangle going there. If this is my reference angle, then this would be directly opposite. Across from your 90 degrees is your hypotenuse, and your leftover is my adjacent, which is what I want to find. So in this situation here, this involves the O and the A. So this would be a tan question. So I can set this up as tan of 42 degrees equals my opposite, which is 18, over my adjacent. I'm going to label this with an x, supposing I want to solve for that. So multiply across by x, you get x tan 42 is 18. Keep in mind that the tan of 42 is a number, divide across by tan 42, and I get x is approximately 20 meters. I know that this length here is going to be 20 meters. I want to solve for this length here. Let's label that with an x. And in which case here, once again, you're in a situation where you have the O and the A. It's going to be tan again, and we're going to go tan of 40 degrees equals my opposite over my adjacent. So x is going to equal 20 tan 40. So x is approximately 16.78. So putting this all together, we end up getting that the height of the building is approximately equal to 16.78 plus the 18, which is equal to 34.78 meters. Okay, let's try the next problem here. So in this question here, we have two observers, spot a plane in the sky. Okay, they've drawn it for us. The angle of elevation from one observer to the plane is 48 degrees, and the angle of elevation from the other observer to the plane is 72. The distance between the two observers is 128 meters. Find the distance of each observer to the plane. So you've got these two observers, and they tell us in the question that they are 125 meters apart. You know the angle of elevation from one is going to be 48 degrees, and the other is going to be 72 degrees, and they want you to find the distance between each observer. So this is like observer 1, and this will be observer number 2, and we want to find x, and we want to find y. So first observation here is I know that I've got myself a triangle. I know this has to sum up to 180, so therefore this leftover angle must be 60 degrees. So therefore I can set up the sine law to solve this here. In this case here I get x over, notice we have the sine law here, I can go x over sine 72 equals 125 over sine 60. So I've got x over sine 72 equals 125 over the sine of 60, in which case we get x equals 125 sine 72 over sine 60, which is approximately equal to 137.27. And likewise, you can do that exact same thing for y. Here we get y over sine of 48 is going to be equal to 125 over the sine of 60. And you get y is equal to 125 sine 48 over sine 60. So y is approximately equal to 107.26. All right, let's try another problem. So for this question here, we've got two ships leave the same location. So, they've already kind of set the diagram up a bit for us, but I can see this location is here. It says one ship travels 125 kilometers on a bearing of 62 degrees, while the other ship travels 75 kilometers on a bearing of 210 degrees. Find the distance between the ships. Well, first of all, this idea of bearing, how bearing works is it measured from your northern direction. So in this case here, if we're going to look at the first ship, is a bearing of 62 degrees, which means the angle from here to here would be 62 degrees. The second ship has a bearing of 210 degrees, so it's going to go from the northern direction all the way around, and that measure here is going to be 210 degrees. Now, we also know some more information. We know that the ship that traveled a bearing of 62 degrees, the length of that was 125 kilometers, whereas this length here is 75 kilometers. And they want us to find the distance between the two ships, which is obviously going to be from here to here. And this is what we want to find. So we've got a triangle going in this direction. And obviously you can see here what we want to do is we want to find this internal angle. Well, if I know that the measure from here to here is 62 degrees and the measure from here to here is 210, if you take the 210 and you subtract the 62, you get that internal angle there, which is 148 degrees. So now we're in a situation where I want to solve for the distance x here, and I've got side, angle, side. So side, angle, side here, I'm going to draw my triangles here. So label this will be A, this will be B, this will be C. Essentially, I'm trying to solve for lowercase a. So this will be a squared is b squared plus c squared minus 2bc to the cos of that angle A that we just found. Well, a squared is going to equal b squared. Now, this is going to be length b, this is going to be length c. So this will be 75 squared plus 125 squared minus 2 times 75 times 125 to the cos of 148 degrees. In which case here we get a squared equals approximately 37,150.9. Taking our square root, we get approximately 192.75 kilometers. All right, that concludes the trigonometry review here. Keep in mind you've got the sine law, you've got the cosine law has been reviewed, even solving word problems with right angle triangles has been discussed here. And then you also have just these 4 types of triangles here I've solved here, kind of cover your sine law, solving your trig ratios for right angle triangles, and cosine law. Thank you. So moving on, we're going to move on to centers of triangles. So in the first question here, they give us 3 points here. So points A, B, C creates a triangle. Let's go ahead and sketch that first. Point A is going to be 2 and 8. Point B is 6 and 2, so maybe it's right about here. There's point B. And point C is going to be negative 3 and 2. Connect this up. We've got just a rough sketch of our triangle, just so we have some orientation and we kind of know where everything's located. Now in this question here, they ask for median line B. Median line B goes from vertice B to the opposite side at the midpoint. So maybe the midpoint's right about here. Again, it's just a sketch, and we just need that for reference. So I want to find the equation of median line B. So in part A, they want us to find the equation of median line B. Well, I know point B. Point B is the point 6 and 2. And I know that this point passes through the midpoint, so I need to find the midpoint of AC. So I'm averaging out the AC values. So the midpoint of AC here is going to be equal to, you add up your x's and divide by 2, in which case here we're going to get minus a half for my x coordinate, and the other one will be 5. So when I go ahead and find the equation of this line here, essentially we're just finding the equation of line given 2 points. So find the equation of line given 2 points. We first found our slope. So slope is going to be change in my y, so in this case 2 minus 5, over change in my x, in this case 6 minus negative a half. This becomes negative 3 over 6 plus a half, which is going to be negative 3 over 12 over 2 plus 1 over 2, which is negative 3 divided by 13 over 2. If you remember, when you divide a number by a fraction here, we can write them both as fractions and just multiply by the flip. This becomes 2 over 13, and we end up getting negative 6 over 13 for the slope. So therefore, if we go over here, let's take a look over here. The slope of this line is going to be y equals negative 6 over 13 plus that y-intercept that we don't know. You can sub in either point. They're both points on the line. I'm going to sub in the point. So we get 2 equals negative 6 over 13 times 6 plus b. B equals negative 36 over 13 plus b. And then b equals 2 plus 36 over 13. And this becomes, getting a common denominator here, we get 26 over 13 plus 36 over 13, and that becomes 62 over 13. So putting this all together, the answer for the equation of median line B is y equals negative 6 over 13x plus 62 over 13. Okay, moving on here now, we want to find the perpendicular bisector of line segment AC. So the perpendicular bisector of line segment AC is going to go from the midpoint, so it's still going to go from here, but it's going to go to the opposite side at 90 degrees. So if you're looking here for the 90-degree angle, it's looking something along these lines here. And you notice it almost looks like a perfectly vertical line when I go ahead and calculate my perpendicular bisector. Well, let's take a look and see if that is actually the case. Okay, so moving on here, we want to find the perpendicular bisector of line segment AC. Well, the perpendicular bisector goes from the midpoint of line segment AC out at 90 degrees. So, we're looking maybe something like that. So I want to find the equation of this line here. Well, what do I know? I know that the line passes through the point minus 1/2 and 5, and I know it's perpendicular to the slope of AC. So the slope of AC is going to be the change in your y. So in this case here, we're going to be taking the slope of this line segment here. So the change in my y is going to be 2 minus 8 over the change in my x, which is negative 3 minus 2, and we're going to get negative 6 over negative 5, which is 6/5. So therefore, the slope that's perpendicular is going to be negative 5 over 6. So in this case here, the equation of this line is y equals negative 5 over 6x plus b. I need to find that b value. The only point I have to sub in here is the negative 1/2 and 5, so I'm going to go ahead and sub that in. So y is 5 here, and x is going to be minus 1/2, and I end up getting 5 equals 5 over 12 plus b, and in which case here I get 5 minus 5 over 12 is b, 60 over 12 minus 5 over 12 is b, and b is 55 over 12. So the equation of this line is going to be y equals negative 5 over 6 x plus 55 over 12. And notice here we kind of see that from our line here. You can see it's it's not a very steep drop, and it is a decreasing linear equation, which is what we got. And like we said, numbers can be messy and continues to be messy in this problem here. Okay, now we want to go ahead and find altitude line C. Altitude line C goes from vertex C to the opposite side at 90 degrees. So if you're looking here, I'm trying to find that 90-degree angle. It almost looks, in my diagram, it looks like it's outside of the triangle, which can happen. And if you remember, it does happen when you have an obtuse angle on there. But again, we just need this for reference. We'll actually determine when we actually create our equation here. So if we go ahead and calculate our equation for this line here, I know that my altitude line is going to go from vertex C, go out and hit that opposite side at 90 degrees. Well, in this case here, the slope of line segment AB is going to equal, we know this is the point 2 and 8, I know this is the point 6, 2, and this is the point negative 3, 2. So therefore, if I want to calculate the slope of line segment AB, that's going to be change in my y over change in my x, and the slope of that line segment is going to be negative 6 over 4, which is going to be negative 3 over 2. So the slope that I want is the perpendicular slope. So the perpendicular slope of AB is going to be 2/3, and therefore the equation is y equals 2/3 x plus b. And then I can go ahead and sub a point in. I only have one point to sub in. It's the point negative 3 and 2. Sub that in here, we get y is 2. 2/3, put that x is negative 3. And we get 2 equals, these will cancel, and I'll get negative 2 plus b, and we get b is 4. So the equation of altitude line C is going to be 2/3 x plus 4. Okay, I just want to wrap up the centers of triangles review. Finishing this off here, we asked what's the centroid, right? There's two ways you can find the centroid. One way you can find the centroid is by intersecting any two median lines. A quicker way to find the centroid is to average out your x's and average out your y's. So in this case here, my x's would be 2 plus 6 plus negative 3, and divide that by 3 to average it out. And then my y's here would be 8 plus 2 plus 2 divided by 3, and in which case we end up getting 5/3 and 4. So again, you can do this a long way. You can go ahead and calculate the equations of two median lines, find the point of intersection of those two median lines, but you will get 5/3 and 4. All right, moving on here, we're then asked how do you calculate the circumcenter? Circumcenter, that's just the intersection of your perpendicular bisectors. So if you take any two perpendicular bisectors and you intersect those, you will have your circumcenter. And what the circumcenter gives you is it gives you a point that's equidistant to the vertices of your triangle. I.e., if you calculate the distance from that point to each of the vertices, you would get the exact same value. And lastly here, they go into the idea of orthocenter. And for your orthocenter, we have the intersection of any two altitude lines. Okay, so that wraps up centers of triangles. Also, if you're looking for an additional review here, the centroid, circumcenter, and orthocenter all lie in the same line. That line is called the Euler line, and that's available for viewing in my playlist under centers of triangles. All right, thank you.